On this problem, we have to find the solution or solutions to this absolute value equation. Look, you already got the absolute values isolated. So if you've got kind of a sharp eye here, you could say, well, my absolute value can't ever be negative. And this equation is saying some isolated absolute value equals a negative number. So right away you should be able to say there's no solutions. But if you miss that, that's okay. It's not the end of the world. You can still go through the problem if you kind of programmed it to just go and attack without assessing it. You can still go about this writing two separate equations. First of all, you get the positive branch, where you write just what you see is what you get. You take out the absolute value signs, and you write down the equation. And then there's the negative branch, where you switch the signs of the stuff inside the bar. So your p becomes a negative p, your minus 7 becomes a plus 7, equals the same thing on the right side. And you just solve each of these. Here we'd have to add 7 to both sides. We'd get p equals negative 7. Here we'd have to subtract 7 from both sides. So we'd have a negative p on the left and a negative 21 on the right, which means p would be 21. And these would potentially be your two answers until you go to plug them back into the original problem. Try plugging negative 7 in for p. It gives you negative 7 minus 7, which is 14. Because you have a negative 14 inside the bars, which turns to a positive 14 when you evaluate it. 14 here is not equal negative 14 there. So this is an extraneous solution. If you plug 21 in for p, you get 21 minus 7 inside the bars, and that's equal to positive 14 as well, instead of negative 14. So that gets thrown out, and as a result, you have no solutions. So either way that you come across the answer, you should have no solutions for the answer.